Hi everyone, welcome to this week's tutorial where we're talking about public data analysis. I'm really excited for this tutorial, mostly because it's a good encapsulation of everything that we've learned so far in sort of all the tutorials that we've progressed our abilities with Jamovi, our application of the theoretical concepts that we've learned about in the lectures. This is really a good litmus test of your learning so far in the course. So hopefully you find it a useful measure of how you're going with your work in Jamovi. So essentially the main overview or outcomes of today's tutorial is to apply techniques learned in this course to real world data. So we're applying everything that we've learned in the tutorial so far and the lectures to real world data that we'll be talking about in a second. And also I'm going to extend that knowledge just a touch to talk a bit about Boolean logic. It sounds scary, but very, very approachable and very, very powerful tool that will help you in a large number of ways. And hopefully I can convince you of if its utility very soon enough. So let's first talk about data. So data is constantly being collected. Some examples include in research, a very typical example where there's a very clear collection of data that's occurring. It can happen through surveys, but it can also happen in a non-research university research context. So it can happen in customer satisfaction, marketing polls. Whenever you engage with some sort of service, they may send you an email or a text after saying, would you mind spending a minute or two filling out our survey? So this is all data that's being collected by the business owners. There's also phone and internet usage. So things like, even there's data on their use of university tools such as Canvas, how much time students spend watching videos, accessing the Canvas site. There's also applications. So when you're downloading apps from whatever app store you download apps from, there's data that's being collected about your usage of the app, right? There's a famous saying that if there's a product that is free, then essentially, well, no product is free, then you are the product, you become the product. And it's because of the value of data. A lot of people have the perception that their data may not matter or they don't care about what happens with their data. If people know what they do, that's fine. And hopefully through this course, you've realized the power of population level data. So whilst it may be true as an individual level, the data you have is not very meaningful. When you collect that and you get a large sample, you can estimate things about the broader population, which allows you to infer things. And if you can infer things, you can predict behaviors, and perhaps even you can change behaviors to alter predictions to have outcomes that are desirable to your purpose. So at a population level, or sample level, there's quite a lot of power in data. So applications, streaming services, YouTube, Netflix, just to name a few. There's a lot of data that's being collected about your usage, which you probably already knew when you looked at the recommended videos, and you find that they're all generally, if you're the only person using the account, it should be pretty accurate in regards to the types of videos that they should suggest to you. And this is based off your previous viewing history, all sorts of variables such as the amount of time you spent watching different videos, search terms that are used, all sorts of factors that target into this algorithm. And you can think of a linear regression as an algorithm. That's all that word means. So it's a predictive model that allows them to predict what you may want to watch next, and it keeps you on the site for longer. Biometrics, this is going to be, it's currently the data now, but really is going to continue to take off into the future as accessing biometric data becomes easier and easier. Things like your sleep patterns, your heart rate and physical activity. This can be easily calculated by a watch or a phone, which can calculate how long you're walking, how many steps you take, your heart rate variability, how long you sleep, whether you have interrupted sleep. And this is really powerful diagnostic tools. It can, at this level, we can have tailored precision medicine where if you go to your doctor in the future and you say, I'm having sleep problems, what's going on? The doctor can look at your sleep data and maybe detect trends as to when you had good sleep, when you had bad sleep, what's happening, what are possible causes. And it allows, rather than the generic thing that most doctors or medical professionals do in regards to treatment, which is, well, common causes of sleep issues are X, Y, Z. They can say, here are the common causes, and here are things that may be more tailored to you based on your individual data. So a lot of power there in improving our health as well. Of course, that's why I say healthcare there. But there's also location data, which is very valuable. Your phone tells you, it can ping your nearest cell tower, which tells you where you are, broadly speaking. And this can be very useful. So, for example, imagine that you're a business and your target market is people in the age range of 20 to 25. Well, if you have access to location data and you know where people who are 20 to 25 primarily are in your region, say in Canberra, you can say, well, look, a lot of people who are 20 to 25 are in these specific regions, maybe near university campuses, or near certain outing places, nightclubs, or I don't know, generalizations, really anything. That would allow the business owner to say, well, to get the most bang for my buck in regards to advertising, it would be best for me to put adverts on university campus, or have sponsorship deals with certain businesses that attract people of that certain age range. And you can see that from location data. So all of this is really, really powerful. Hopefully you're not getting too scared about the way in which data is collected. But in any case, if this is new information, it is good to know how your data is being handled and collected. Data privacy is something that people sort of stumbled across because the internet advanced much quicker than laws and regulations in regards to how data is used and accessed. And so really, really important points. And as I noted, healthcare with, especially in Australia, how it's linked in the site, you can opt in, I think, opt out or opt in, one of those two options. We know from this course that for retention of candidates, it's easier to have a opt-out service than opt-in, but it requires consent. So you need to make sure participants are fully informed when it comes to research. And we talk about, there's a thread on Reddit even in regards to data is beautiful, which refers to it has amazing ways in which you can simulate and graph data. And often there's examples of real world data that are there that people have graphed, I don't know, time spent during lockdown or all sorts of things. So I'd encourage you to check out that thread and use some of the skills that you've learned so far in this course on that thread. But this essential slide hopefully emphasizes that you have data. Your data is valuable for a number of reasons. It's collected in a number of different ways. You may or may not be aware of it, but as we progress, it seems like people are getting better at disclosing how data is being collected. The next question becomes, well, what are the powerful ways in which we can use this data? And so we've talked about some of those ways there, but important considerations include, when we talk about data, is privacy, which we've talked about briefly in regards to your data that you own. How much of that data are you aware that you're giving up that privacy? But we could go into a whole lecture about data privacy, but if you're interested, there's many resources out there that talk more about data privacy and how to protect your privacy. Digital footprint is another point, which I won't go into too much detail, but just to be aware of that, I guess a lot of people stumble into their digital footprint. I really encourage you to go on any browser and search your name or search details about yourself and see what comes up and see what data is publicly accessible about yourself, because it'll be interesting to know when we talk further in this tutorial about the ways we analyze data, what publicly available data is there that people could analyze about you. Speaking of, again, another data collection method is Google. Well, even using your search browser can include ways in which the company collects data about your search terms and understands how that is being used for many different ways. So there's other browsers out there as well. DuckDuckGo is one. Brave is another one. There's lots of browsers that really value privacy and data protection. And so there are publicly accessible data sets that are available. The Australian government has data that's available, that they make available. Now, again, it's a close consideration with privacy as well. When it comes to the Australian government, there are some ways in which data is collected or data is reported where they'll change the numbers a bit. It's called perturbing the data. And that's when they slightly change the numbers if they feel that there's some risk to individual privacy. This is often done in census collection. So if say you're in a location where there's not a lot of people who are, say, elite sport athletes who earn over $1 million, if you could be identified as someone who lives in this suburb, over $1 million sports athlete, then that means that the ways in which the data is reported, the numbers can be changed slightly to blur this. So they can expand the regions so it incorporates many people who have fit in this criteria, so it anonymizes participants. So there's lots of ways in which the government works to do this, but there are freely available resources that you can analyze with the data, and that's the link there allows you to do that. GitHub is a repository that is a tool in which people really track their work that they do on all sorts of things. It can be documents or data analysis, but they also post their data. In research, there's a big push to have people not only publish their research, but where possible, publish their data. And if they can't publish their data due to privacy reasons for the participants involved, they can create simulated data sets and publish that, which has the same distribution of values that reflect what is being reported in their paper. So you get a sense of that as well. And so I've linked here a GitHub repository, which is an account that has a list of huge amounts of data sets. So anything there, you can have a play around. If there's something that interests you after today, you can see some of the skills that we apply and apply it on some of these data sets. There's also preprint servers, so PsycArchive, medRxiv, and bioRxiv, and this is where people publish their paper before it's been peer reviewed, just to let the public review it, other researchers review it, so it's not delayed in publishing, and it also allows people to publish their data as well, and people can redo the analyses and see if it matches up with what's been reported. So these are all really useful tools in which, if you want to practice more about even Jamovi analyses, you can check some of these data sets out, load them in Jamovi and play around. So these are some examples of what you can do. And we're going to do just that with the Gapminder dataset. So Gapminder is another link there that has freely available data, which is collected about all sorts of global statistics on countries around the world. And so we're going to be using a dataset from Gapminder. So this is real data that we're going to analyze. So hopefully you can see the utility in what we're doing and all the skills that we've learned in this course applied on a real dataset. So let's get stuck into it. So first is open the Gapminder dataset, which I have in front of me here. And here's a series of questions. Now, for most of these questions, I'd encourage you to sort of pause the video and have a crack at doing these questions before we do them together. But I'll trust that you pause them at certain sections. But if not, we can always do them together. So the first question is, how long are people living all around the world according to this data set? Generate descriptive statistics and a histogram. So first thing we do, we can inspect the data. We could have a look at how many rows there are. So if we go all the way down, we can see there's quite a lot of data, and you'll see this a lot with real data sets, is that the amount of data is quite large. So we have 1,700 rows of data. We can see something interesting here, that there's multiple rows for the same country, and this is because it's of different years. So we have 1952 all the way to 2007, and this applies for all sorts of countries. So again, 2007, 1952. And it gives us data on life expectancy for these countries in these specific years, the population at that time, and the GDP per capita. So this is all information available in the dataset. So it's quite a large dataset that we have here. So first question, how long are people living all around the world according to this dataset? So we can go into descriptives. So we go analyses, which were here, exploration, and descriptives, which is some of the first things we learned in this course and how to do in Jamovi were descriptives. And we'll generate descriptive statistics and a histogram of life expectancy of people all around the world. So we just move life expectancy across. And we see here that on average, people are living to, the average age is 59.47. Global average is 59.47. Something to consider here is this is the global average between 1952 to 2007. So it's not a specific year, it's actually a collection of years. This is what the average is in these decades. We can generate a histogram by going into plots, histogram, and we get a nice histogram here that's been generated that shows us the life expectancy overall of all these countries. So that's a descriptive statistics and a histogram that we've generated for life expectancy. Let's do the next question, which is, does worldwide life expectancy change across the years in the data set? I.e., are people living longer as we progress through time? Yeah, so does the life expectancy change across years? So as we go from 1952 to 2007, and are people living longer? So to do a question such as this, we need to ask ourselves, what's the dependent variable? What are we measuring? And what's the independent variable? What's changing? So what we're measuring here is life expectancy, right? What is life expectancy? And what we're changing is the timestamp. So it goes from 1952, 1957, and we go on from there. So let's generate a scatter plot to do this. So we go analyses, exploration, and scatter plot. Remember, you need to have the scatter package, which we've downloaded previously. But if you don't have it, it's behind my face here in the modules to download the scatter plot or scatter package. And so to generate a scatter plot, we think about what should go on the X and Y axes. So usually the dependent variable goes on the Y axis, the thing that we're measuring, and the independent variable, the thing we're changing, goes on the X axis. So the Y axis, the thing that we're measuring, is going to be life expectancy. So we'll put that in there. And the thing we're changing is a year, right? So how does life expectancy change as we progress through age? And we get a nice little scatter plot here. And so we can see here that as the years progress, so as we go along this x-axis from 1950 to 2000, we see life expectancy. Typically the trend is it's increasing, right? And there's interestingly, there's some outliers that we see here, but generally we see an increase, which matches real world statistics, mostly because this is real world data. So it shows that as we progress, people's life expectancy is increasing. So that is that for that question. The next question is, how does the relationship between year and worldwide life expectancy vary by continent? So we have already the relationship between year and life expectancy. And so that, how does it vary by continent? So I'd encourage you, and we're generating a scatter plot. So have a think, what would we need to do in Jamovi to change this graph? Because it already has year and life expectancy. What would we need to do to change this graph to make sure that we can see how these trends vary as a function of continent? Hopefully you've paused the video, but if not, that's fine. What we do is we put continent in our group. We put continent in our grouping variable, and we can see here each of the different continents listed, and we see the life expectancies. And we see some clear trends emerge. We can see that people in Europe broadly have the longest life expectancies that we see as people age. And the lowest ones are people who live in Africa. And then in the middle, we have other continents as well. And we can even make this clearer by playing around with some regression lines. We can put in a linear regression line. And it can show us that actually even Oceania, which includes Australia, is the longest. So this is the value and utility of putting a regression line. I couldn't even see those pink or purple dots as a result of all the dots that are there. So it gives us valuable information on the order in terms of life expectancy, and also the trends, and whether the trends differ by continent. And we can see that broadly, whilst there are differences in life expectancy between these continents, we see an increase in life expectancy across all these continents. Some are increasing faster than others. Asia, the life expectancy is increasing quite rapidly there, comparatively to other continents, but we see some nice trends. And this is really a publication quality plot. Some things you would want to change in a publication quality plot is maybe the year and life expectancy, the names of these variables, maybe give a title. But really, what I want to show is that you can do publishable analyses on real-world data using Jamovi. So it's a very, very, hopefully you're very excited about this. As excited, or if not, appreciate my excitement about this. What is the life expectancy of Australians? Let's ask this question. So again, this is another question, so feel free to pause when there's a new question and then have a crack. If not, we can do it together. So the hint here is to use filters, then plot the scatter plot as before. So this is really testing your knowledge of how to use filters. So to use a filter, we go to Data here, and we click Filters. And then we can filter out just Australians. So to filter out Australians, we need to select a variable that specifies Australians. So we can do country equals Australia. So to do that, we go country equals Australia. And then I press enter. And you can see here how all the X's are for other countries. But for Australia, it's all green. Green ticks here. And then automatically our little plot here will update to what we see in regards to Australia, part of Oceania, which is the year and life expectancies there. But we can go through the process again of plotting it with analyses, exploration, scatter plot. And now if we were to put life expectancy again in the y-axis, and we put the life expectancies of Australians. Yeah, so if it's of Australians, we just put year in the x-axis, and then this is just for Australians. And the way I know that it's just for Australians is because the data set only has Australians applied in the filter, and that's what we see there. So you can see here it's exactly the same, just this one doesn't have the group there like we did previously. So Jamovi automatically will update your figures based on filters, so it's something to keep in mind. So that's a nice little scatter plot that we have, and we can see it of Australians. So the next question is, how do the trends in life expectancy for Australians compare with those living in Ireland? Now don't actually stop the video here, because this requires new content knowledge, which is Boolean logic. So what we'll do is I'll actually pause there. You can have a review of what we've done so far. And then when we come back in the next video, we'll kick it off with some Boolean logic. All right.